everyone, welcome to the third video of Module 7. And here I'm going to give you an idea of what is the artificial neuron and then compare it with the biological neuron in a way that I'm going to help you understand that how exactly this kind of artificial neuron works. So let's get started. On the right, we are having a biological neuron, and then on the left, inspired from the biological neuron, we have an artificial neuron. So let us first of all understand that how an artificial neuron works, and then we are going to compare it with a biological neuron. So now let's get started with the artificial neuron. We have always looked into the tabular data so far, and we have known that all the input columns over there are called as independent features, and then there is a target column which we call as a dependent feature. So each of these columns are what we call are the features that we have in our data. And if we are talking about the independent features over there, each column over there can be called as one independent feature. Now, all of this kind of input features that we have in our tabular data, we can feed it to our network with the help of this kind of orange boxes, which are nothing but the input neurons. So each box can take the data for one particular column. So as you can see that there are 6 orange boxes over here, or 6 different input neurons. We can feed in 6 independent features over here. Actually, depending on the tabular data that we are having, how many independent features we are having in our data, we can come up with the number of orange boxes that we want to have. So right now we are assuming that we are having 6 independent features, and therefore we are having 6 neurons over here that are the input neurons. But now let's talk about what really happens into this artificial neuron. These are the input neurons. Okay, now we are going to talk about the artificial neuron. So over there, the working is very much similar to what we have already seen in the logistic regression. That is, first what we do is we always give weight towards each and every feature that we have in our data. That what is the weight that we'll be having corresponding to the x1 feature, then what is the weight for the x2 feature, x3 feature, so on and so forth, just like exactly what we had done in our logistic regression. Then what we do is we take this kind of a weighted average, that is we do x1 into w1, x2 into w2, x3 into w3, all the way up to x6 into w6. We do all of this and then also add a bias term. And once we get this is called as the unactivated output. After this, what we do is we activate this output with the help of some of the activation function. And in the logistic regression, we had looked into this as a sigmoid activation function. So let's, for now, for the simplicity purpose to understand how a neuron works, let's keep that activation function to be a sigmoid as well. And this is exactly how a particular neuron is going to work in the artificial neural network. So I hope this part is clear, that it is very much similar to how a logistic regression works, but there is a slight difference. Over here, activation function is not always sigmoid. For different type of tasks, we can come up with some different type of activation function. That's one difference that you need to keep in mind. Alright, but every other working, that is this unactivated output Z, is always same like how we do in the linear regression as well as the logistic regression. But on top of that, what type of activation function you are going to use is actually what is dependent on the type of the task that you are dealing with at that point in time. Well, let me make this kind of things a little bit more easier for you to digest. For that, let's take 2 different type of scenarios. In the same type of neuron that we are having over here, we can use it for the binary classification as well as the regression. So if we are dealing with the binary classification, at that time, the activation function can indeed become sigmoid, because you already experienced this kind of thing in your previous module. I hope this part is clear. But now let's say if you are dealing with some kind of a regression task, in that particular scenario, you can use an activation function as ReLU if you have to. And that can be useful for the regression purpose. So yes, I have given you one just quick example with 2 different scenarios, that how we can use some different type of activation function on the basis of what type of task we are dealing with. And that's the difference that we are having in the logistic regression and then in this artificial neuron. We are having a lot more activation functions and no need to be worried about it, because we have taken care about this activation functions in the later part of this particular module. So it's completely fine. Over here, the main purpose was to understand that how an artificial neuron works and how similar it is to this linear regression and logistic regression that we have already covered. So I hope that part is clear. And now it's the time to go ahead and look into the biological neuron. And then we are going to compare it with that how closely artificial neuron is depicting the biological neuron. So over here, we are having the structure of the biological neuron comprising of dendrites, nucleus, and together we are having the cell body, then the axon, and at the end we also have the synapse. I hope I am pronouncing this word correctly. I do apologize if in case I am not pronouncing it correctly. So now the dendrites are responsible to receive the signals from the other neurons. It is very much similar to the inputs that an artificial neuron receives. So if I just go back over here, you can see that this is exactly what I'm talking about. These are the input neurons which are responsible to give some kind of the information to this particular neuron. Then we are having the nucleus, which is responsible to control the behavior of this neuron. For example, this is very similar to the activation function that we had seen in our artificial neuron. Because in the activation function, what type of activation function is going to govern the output of that particular neuron? So we had taken this example of if it's a binary classification, we can use this as let's say sigmoid activation. If it's a regression task, we can use this activation function, for example, as ReLU activation. So this activation function that we choose is going to govern how the output of that neuron is going to be. And therefore, we can compare this nucleus with the type of the activation function that we are going to choose for that particular artificial neuron. And now let's talk about the axon. So axon conducts the electrical impulse from the cell body towards the axon terminal. Now this is very much similar to the unactivated output that we had seen in the artificial neuron, which is nothing but the x1 into w1, x2 into w2, and all of this kind of weighted average that we take, plus the bias that we have for this particular neuron. And this is nothing but the unactivated output. So this axon is very similar to that. So on the basis of this unactivated output, if we implement the activation function, we are going to understand if this particular neuron is going to be fired or not fired. If it's fired, it will be connected to the new neuron that will be attached to this particular neuron. If it's not fired, the connection will be broken right over here. And therefore, the next step that we have is the synapse. This is the part which gets connected to the dendrites of the other neurons. And this is nothing but the activated output, where we apply the activation function on this unactivated output. And if the output is such that it fires the neuron, it's going to build the connections of the further neurons. If it's not activated, it's going to break the connection. So just imagine in a whole neural network architecture, you are having bunch of different artificial neurons. So depending on a particular neuron, if it will be activated or deactivated, you are going to decide the whole structure of how the information is going to pass from the input to the output. To be honest, a lot of this kind of things will be cleared in the next video once we jump into the architectures of neural network. But yeah, here was a quick introduction about how we can compare a biological neuron with an artificial neuron and can think about how is it very much related to the biological neuron because it is inspired from the biological neuron itself. So I hope that particular part is clear. So just to give you a quick summary, dendrites are the part of the inputs that we are going to get to the artificial neuron. Then the nucleus is the part where we decide what type of activation function we are going to use to control the type of output that it's going to give. And then this axon is like the unactivated output where we are having a particular value that we get on which we implement the activation function that we are having is the nucleus. And then if on that particular basis, if the output is activated, basically if the neuron is activated, it can be connected to the further neurons. And if it does not get activated, the connections is still there, but it's going to be broken. That's the whole idea. So now I hope that this part is very much evident and clear to you that how can we relate an artificial neuron with this type of biological neuron. Now, if this part is clear, let's move on towards the last part of this video. That is, what is the mathematical intuition of an artificial neuron? How it works mathematically. And we are going to understand this with the help of one example. And if you are someone who has already looked into the previous module and know how a logistic regression works, then understanding this mathematical intuition of an artificial neuron is not going to be difficult to grasp. So over here we are given this particular tabular data with set of 6 different independent features which are nothing but the inputs, and each and every feature is coming up with one individual sample. It's not more than one, it's only one sample. Then over here we are having this particular data corresponding towards the weights for the respective input neurons. So W1 corresponds towards the X1 input neuron, W2 corresponds towards the X2 input neuron, so on and so forth. W6 is corresponding towards the X6 input neuron. And along with that, we are also having a bias value that is associated with the artificial neuron. Now, given this particular scenario, we are asked to calculate the output of this artificial neuron with the sigmoid activation. So yes, as you can see right over here, this is nothing but the calculation that we have already performed a lot of times in the previous module when we were dealing with the logistic regression. But I hope you keep one difference in mind. That is, if this particular activation was something else, not sigmoid, then this won't be any more a logistic regression. Okay, for a particular neuron. Remember guys, a whole neural network is composed of this kind of different artificial neurons. So in a way, neural networks are different from the logistic regression, but each and every neuron can work like a logistic regression if you think about it. And that's what I'm going to show you in the next slide. So to calculate this particular output, what we are going to do is, first of all, we are going to calculate the unactivated output. So over here, if you remember the formula, that's how it's going to look like. We are going to have the x1 into w1, x2 into w2, all the way up to x6 into w6. Once we are done with that particular calculation, we are going to add a bias towards it. And then whatever is the mathematical calculation you do on your calc, this is the answer that you're going to get. That is z is equal to 0.96. Remember that this is an unactivated output. Even though it's between 0 to 1, this is still an unactivated output. We haven't implemented any kind of activation function, guys. But now, because it was the necessity of the question that we implement the sigmoid activation, if you remember from the previous module, that's how a sigmoid activation is going to look like. So if you implement the value of z as 0.96 in the formula, 0.723 is what you are going to get as a part of the output. So this is the activated output, guys. Now, whether or not this particular output will be connected to the neurons further to it will be dependent on if with this particular value we have fired that particular neuron or not. So let's say, for example, if we set the threshold of this particular neuron as 0.8, so in that case, this is not fired and therefore the connection will be broken. But at the same time, let's say if we are setting the threshold over here as 0.5, so because this value is above 0.5, this neuron is going to be fired and therefore all the connections that are associated with this particular neuron will be activated. So yeah, that's about the mathematical understanding that we need to have about how an artificial neuron actually works. So yes guys, that was about the artificial neuron. I hope you were able to understand it and enjoyed this whole session. Now in the next video, I'm going to show you the multi-layer perceptron where we'll be building this kind of neural networks. It's going to be really very fun. Stay tuned for that.